Thank you, Jay. So today we're going to learn about securing Python applications. And there's a reason why I'm the best person to talk about insecure code, because I remember back then, the reason why I found myself into cybersecurity is because I actually got hacked. And then I became very curious on how to actually build more secure products. And that's why I say I usually went to Google University or YouTube University just to do that self-analysis around how I can build more secure products. Yes, but that aside, my name is Jolene Kirui. I'm a senior cloud security advocate at Microsoft. You can find me on Twitter and on LinkedIn. Those are my handles. And just to jump off into the presentation. So this is what you're seeing everywhere. Insecure code everywhere. And it's very important just for us to understand our role as developers, because I always say developers are our first line of defense. And the reason why I say developers are our first line of defense is because we know when we are doing insecure code, because sometimes it's just a lot of time as well to actually do things correctly. But at the end of the day, you have to understand that it's your stake. You have to have a security first mindset whenever you're building these applications. Otherwise, your company might be hacked, your customer data might be leaked. And there's a lot that goes around afterwards with that. So it's very important just for us to understand why it's very important for us to talk about secure development, because we find that 50% of companies actually sacrifice cybersecurity for speed. And because you find that you probably announce that you have a big feature going out maybe on Friday, and then after that, probably the security team comes in and then they say that there's a huge security vulnerability that has been found, which is of high severity. And they say that if you move forwards, there might be some consequences. So in most cases, you find that companies actually sacrifice that cybersecurity issue for speed because they had already announced. And then we find that also ops team, they push back on several security best practices as well, because you'll find especially in companies where they still have like legacy systems, and then our security folks give them like a whole list of security vulnerabilities. So it's very hard for them to actually deploy and have the best practices in place. And also, I don't know, maybe you can also tell me on the chat, are you trained to code securely? So another statistic that I really like showing is we find that 80 to 90% of code in new applications actually comes from open source. So normally we say that 80% is code that is actually borrowed, and then 20% is actually code that you yourself have actually coded yourself. So you can imagine out of the 80%, that's what we call third-party dependencies, open source libraries that incorporates 80% of your code base. And the 20% is one that you've actually coded. So out of the 80%, how much of it is actually secure? Ask yourself that. So the other sources of vulnerabilities as well, we see that we have unchecked dependencies. That's 80% of the code. And then there's also employee error, where we're talking about exposed access tokens and safe coding patterns as well. So we're going to chat a little bit about that going forward as well. And now in the era of AI, we are introducing Gen AI applications. So beforehand, we had all these security vulnerabilities, and then now we're introducing Gen AI applications. So that does not mean that all the other vulnerabilities reduce. It just means that the threat landscape has actually increased. So these are all the things that we look at in our code base when you add Gen AI in terms of the new threats that have come in. So you can see in each of those components, we have very many new components. Like right now, we're seeing something that we didn't see 1 year ago, which is something like direct prompt injection. That's a new vulnerability that's coming with Gen AI application. And then we also have sensitive data leakage, unauthorized access, oversharing, over-reliance, model denial of service. So denial of service was there before, but right now, since we're talking about AI models, there's now that element of model denial of service. And you can see, yes, this is a very busy slide, but if you can, just click on this, because it's very important just to understand the threat landscape around your application So you have your Python application already, but you also have now introducing Gen AI as well. So these are all the things that you're seeing right now in terms of security vulnerabilities. So this is one of the applications that we have. You can access it in aka.ms/ragchat, which Pamela and the awesome teams within advocacy built. And for me, the reason why I have to show this is the architecture diagram of it. And the one thing that we always have to do as developers is to have a threat modeling done. And threat modeling is done when you have your architecture up and already. So we have this tool called the Microsoft Threat Modeling tool. And as long as you have the Microsoft Threat Modeling tool, you can now drag and drop these architecture objects as stencils within that tool. And then it will tell you which components are actually vulnerable to which threats or risks as well. So threat modeling is something that we always have to do if you're introducing any new component to the new application, do some threat modeling. So if you're introducing a new API, you have to understand, so is it public facing? Is it private facing? Have I put in the right controls into like rate limiting to protect that application from being compromised? So the reason I was showing you this is so that you can understand, okay, what better ways can we do our security throughout the whole architecture? And one thing that you'll notice here that was different from the previous one, we have this component of login, which is quite important. So authentication and authorization is quite important. And that's what I'll be showing you today as well. And then this component of application UX. So you probably have your website and then you have your Gen AI app embedded there. So even if you are building a Gen AI application, it is still code at the end of the day. So I'll also be showing you how you can be able to secure your Python code, the 80% that you've just borrowed and the 20% that you've coded yourself using GitHub Advanced Security. So for today, that will be the main angle that we'll be showing you in terms of deploying and making sure that the code that you're building is secure, and as well as adding authentication within your application. I hope you are looking forward to that. But before we get into the demo, I want to show you what we have in terms of the threat landscape. So every 4 years, OWASP actually releases security vulnerabilities according to what they've seen trending in the last 4 years. So you can see what was there in 2017 was quite different from what is there in 2021. So when you're looking at the code here, we're seeing right now the top issue that we're seeing in applications is broken access control. And then you're also seeing now the others are now cryptographic failure, injection, things like SQL injection. You've probably heard of SQL injection. And then there's insecure design. I showed you the design, the architecture before, and then I showed you another architecture of how you can be able to make sure that your architecture is flowing well, that you have everything considered, you have authentication, you have data and access control deployed within that whole architecture. And then now we also have vulnerable and outdated components. So I spoke about the 80%. So that's where we have the vulnerable and outdated components. And I'll show you right now how you can be able to fix that real quick. So I'm very sure most of us are using GitHub GitHub. And we have this cool feature called GitHub Advanced Security. So GitHub Advanced Security has several features that are available that will be able to give you the checks on the 80% of the borrowed code and the 20% of the code that you've actually written yourself. And all you have to do, by the thing I like about GitHub Advanced Security, you can play with it even right now for free because it's available for all public repositories. But for private repositories, you have to pay for a license. So you can see here, I have a vulnerable Django application. And all I have to do within GitHub is to go to settings and then scroll down to code security. In code security, we have this private vulnerability reporting. So this private vulnerability reporting is more like a bug bounty program within GitHub. So if you enable this, researchers can come in, and then if they find any security vulnerabilities within your application, it will tell, so they'll report and then they'll be given some amount of money as well. So this private vulnerability reporting is also important, something that you can consider. But the key things that I want to highlight is Dependabot. So Dependabot scans your whole code base for dependencies, and it scans now the 80% for now the third-party dependencies in the open source library for any security vulnerabilities. And then it will list all of those within the security dashboard. So you need to enable that. And then you also have Dependabot security updates. It bundles up, it creates a pull request for you with suggestions on how you can be able to fix all those dependency issues. And then the other component that you need to enable as well is code scanning. And the thing I like about GitHub Advanced Security code QL analysis for code scanning, it actually detects. So if I disable this code QL right now, and then I set it up real quick, I use the default settings available. It will automatically detect the kind of language that I'm using within my repository. And then all you have to do is now to enable CodeQL. So it will scan through each line of code to give you any security vulnerability that's available there. And then the other important aspect that you have to look at is secret scanning. You have to make sure that secret scanning is enabled. And the best practice, if you have any secret that's embedded and then it's found, you have to revoke that secret as much as possible. And also make sure that right now, even in the era of AI, we want to move away from stuff like API keys as much as possible and use managed keys as much as possible, because you don't want this scenario whereby you are always shuffling your keys, you're always forced to revoke your keys because it has been compromised. And the other thing that I really like about secret scanning as well is push protection. You have to make sure that you have this push protection enabled. So push protection prevents you from actually merging to your repo if it actually finds any security, any secrets. So if you're available like on Visual Studio and you're trying to push your code and it finds a particular line of code that has secrets, it will prevent you from merging that line of code. So that's why it's very important for us to enable this. It's cool, right? So let me just quickly show you the kind of insight you get. So for Dependabot, I mentioned it's for the 80%. It will find that for this one, it lists them according to severity. So in security, we usually list our security issues in terms of critical, high, medium, low, informative. So you find here that this one is almost certain that we're vulnerable. So we find here that our number one issue is SQL injection in Django. And then all I have to do here is to review the security update. It has already created a pull request and given me suggestions on how to fix it. It has told me that this particular version between these allows this particular SQL injection because there's untrusted input from a client of a web application. So let's review that. It has created the pull requests. All I have to do is to merge that pull request for it to actually fix that dependency issue. The other thing that you need to check as well is code scanning. It tells you which line of code is actually vulnerable. As you can see here, it gives you the suggestion on how to fix it. And it tells you that code that passes user input directly to exec or some other library that executes a command allows the user to execute malicious code. So it gives you that overview, and you can be able to go in and see how you can be able to fix all those code scanning issues. And as well as secret scanning, it tells me, like for this Slack API key, it tells me this line of code, and this one is actually publicly exposed, gives me recommendations on how to retrieve the secret, revoke the API token, and also to check the security logs for potential breaches as well. Because in most cases, if an attacker is compromising your application, they'll be able to go into the logs as well. You can be able to tell from the logs if something was done. But what most attackers do, they also clear up the security logs so that it's very hard for you to know if you are actually compromised. Okay, so that's an overview of secret scanning. And it's very important just for you to understand what is within your code base and which one of them is actually vulnerable. And then the other component that I spoke about earlier is having authentication within your application. So it's very important just for us to understand what are we talking about in terms of identity. So when you're talking about identity, we are seeing a lot of reports as well, even from the MSRC, our Microsoft Bug Bounty program, is that you'll find that maybe in this case, tenants and administrators can actually create users with any email address. And the consequence of this, you find that maybe this create admin was able to create a user for our vendor that's using this particular email address. And you see, this gives some bit of authentication issues whereby you have potential of privilege escalation in Azure AD applications. So what can we do about this? I like this meme because this genie is saying there are three rules: no wishing for death, no falling in love, no bringing back dead people. And then we have this, but I want to write my own authentication and authorization. And then he's like, no, there are now 4 rules.
Hey, Joanne, I just wanted to make sure you knew we got about 5 minutes left in your session, but please continue.
Yes. So the goal here, remember we've already scanned our application for security vulnerabilities. We've done the code scanning, we've done the secret scanning, and we've done the dependency scanning as well using GitHub Advanced Security. So the other component in terms of securing our application is to make sure that we have the right kind of authentication and authorization within our application. And the whole goal here is to make sure that we have the right kind of authentication within our application. And the demo that we'll show here is using that particular repo that we have up. But you might be wondering, so what is authentication and what is authorization? Authentication in most simple terms is because normally we use like username and password, it's that identifiable quantity that's given to a particular person. So like for me, I have the username maybe Joylene Kirui, and then authorization is to see if I have the right access to a particular resource. If I should have access to that resource, then I should be authorized to access that particular resource. So in this case, for authorization using Auth2, and for authentication using OIDC. And you can see here, this is the simple flow for Auth2 authentication flow with OIDC. And we're seeing that we have this request that's going in, and it's quite complicated to actually do this correctly. And that's why it's very important just for us to use the built-in authentication that's available for our application using the built-in authentication that I'll show you shortly. So typically developers would need to build custom logic on their backend to verify the authentication code flow and handle auth and return an access token as well. So this process can be time consuming and requires considerable development effort to manage authentication. So that's why it's very important just for us to go in and see how we can be able to use the built-in authentication that is available. So instead, we'll use the Azure's built-in authentication for app service, which intercepts requests, figures out which users are not logged in, manage token issuance as well, and redirect the users back to the application upon successful sign-in. So this allows you to focus on building application features while the platform manages authentication and authorization for you. Okay, so just to give you an overview of what you have here, we can see here, let's just get the code base stopped. If you have any questions, please let us know. But this is just an overview. I'll give you the link to this application as well. So what we want to do is to use the built-in authentication using Microsoft Entra. And you can see here, this is what we want to achieve in such a way that you can be able to sign in using your user. And the thing that's very important here is to make sure that you have Microsoft Entra ID set up. And all you have to do within Microsoft Entra ID setup is to make sure that you have the right tenant here. So if you're using like a work tenant or an external tenant, you have to set it up within this code within, because you're deploying using Bicep. And then you also have to make sure that that you have your AZD auth login to the right tenant that you have deployed. So the main difference between Entra ID and external ID is the kind of tenant that you're going to deploy, because for external ID, all you have to use is an external tenant for your application to run.
Wonderful. Well, right now, I think we don't have a ton of questions, but I just wanted to say, as someone that has worked in the world of system administration and dealing with applications and DevOps, security never seemed to get as much attention as it really was due. And so I feel like what someone like yourself and other members of like the security community do is really give people things to think about. What do you say right now for an application developer is probably the most important thing for them to look at regarding security before shipping to production?
Okay, so I have one last slide that
Sure,
will show them how to actually summarize this.
Okay.
I created this just for them to be very easy for them to understand. So it's just a simple one slider that you can just screenshot and live by it. One thing that you have to do is always do input validation, because what garbage in, garbage out. You have to do error handling, the correct error handling. Access control is quite important. Secure data storage, secure communication. Make sure that whatever is being transmitted is secure. Whatever is in transit is secure. Whatever is in storage as well is secure, because you never know who's listening. You also have to make sure that you have the right secure session management, the right secure coding standards. That's why I showed you the OWASP top 10 vulnerabilities, and as well as having regular security testing. So we have like tools like GitHub Advanced Security, PyLint, PyChecker, and Bandit. Tools like Bandit are specifically for Python application. And then you also have to keep your software up to date, and as well as have the right security awareness training every so often. So I hope to see more and more of you being security champions.
Very, very cool. That actually really answered my question completely. Well, Joylyn, it's been wonderful to have you part of this today. And I know our viewers are really, really glad to hear how much of a focus security needs to be for them when they're building applications. So thank you very much. And hopefully we'll see you next time. Have a great rest of your evening.